Alright, this is lesson 16, complex numbers. This is a whole new world of math for you now that you're in Algebra 2. So, all through your life we've taught you what real numbers are, and we never really specifically said they're real numbers. We kind of did, and you're kind of like, oh, they're real numbers, duh, they're real. So, like, when you have the number 10, or if you have $10, they're real. There's really $10, right? You could use the $10 and go spend it, right? Well, there's a whole nother set of numbers that are called imaginary numbers. Kind of like people have imaginary friends. They don't really exist, but to them they do. They're like, I see dead people, and they're, okay. So, same thing with math. They're not like dead numbers. They're just called imaginary numbers, and there's just another field called imaginary numbers. It's just something they did in math. You need to kind of know what that means and how to deal with it. But it's just like dealing with any other variable. I'm going to teach you what they are. So, when we have real numbers and imaginary numbers together, we call those complex numbers, okay? And I'll explain that in a moment. So, an imaginary number is denoted by the letter I. So, and what this means when we see I, it just means the square root of -1, okay? When we have I squared, it's going to be -1 times -1, which is, or square root of -1 times square root of -1, which is just -1. When we have I to the third power, I to the third power is like saying the square root of -1 times -1. And then I to the fourth power is just -1 times -1, which is just +1. Okay? Yes.
Okay, now, on the first one, for I squared, you get -1. How do you get 1 for I to the fourth power?
Because if I squared is -1, I squared times I squared, which is I to the fourth, is +1, right? So this is going to be kind of confusing, and you're going to kind of feel strange about this lesson, and that's okay, because this is kind of all new, all right? And we're going to briefly touch on this. This isn't like a huge deal in your math life, but you kind of have to know how to deal with it. So as you're writing that down, let me tell you how it relates to you. So before, back in the day, what's the answer to square root of 4? 2. Would you all agree?
Yes.
Okay, what's the answer to square root of -4?
-2.
No. Well, what's -2 times -2? +4. Is that the answer? What's 2 times 2? Is that the answer? 2? So whenever we had a square root of a negative number, what did we always tell you? The answer was always no solution, right? Do you remember that?
Yes.
Okay, we told you that all, even through Algebra 1, because we're like, well, we're not going to talk about this until later, okay? No solution, we just don't deal with it, okay? Now when we say square root of -4, this is where the complex numbers come from. So, like I said, square root of -4, would you agree that square root of -4 is like saying -1 times +4? Yes or no? Okay, what's the square root of 4? 2, right? What's the square root of -1 then? Look at my I, right? So square root of -1 is really like saying I, so we could say that this is 2 times I or 2I. Okay, that's the answer, 2I. That's it. Okay, so this is just a pre-example. Write this down just for a moment. I'm going to show you 2 examples that like normal, okay? Actually going to have you write the steps. Did you write the steps yet or no? Okay, so these are the steps. Here you go, numbers 1 and 2. Actually, before that, why do we do this? Why am I doing this? And I like this idea. We have imaginary numbers in math. Like we've taught you like the big picture of math, add, subtract, multiply, and divide. And then when we go into like higher levels of math, you're kind of looking at things in more detail, just like a biologist. Or when you're a little kid, you're like, your mom is all like, well, what color is that thing? What's that called? You're like, that's a plant and it's green. Okay, and you're like, that's great. And you've always said that. And biologists back in the day, they probably thought, okay, plants are a stem, a leaf, and roots, right? Would you agree? And that was as much detail. But then they invented the microscope, and what do you see when you have a microscope? You see detail, right? You see cells, right? And then now, biology, you take that class, and you're like, oh, wow, there's all sorts of stuff. There's a membrane, there's a nucleus, there's mitochondria, right? So there's all sorts of details, just like with math. So there's always more than meets the eye in mathematics, and that's the same with life. There's always more than meets the eye, all right? So here you go, numbers 1 and 2. Watch carefully. We have rad negative 32. So usually we said the square root of a negative number is going to be no solution, but we know that rad negative 32 is just like the following. It's going to be negative 1 times 16 times 2. Okay. We know that the square root of 16 is 4. Square root of negative 1 is I. Square root of 2, there's nothing there, so we just leave that inside. So our answer is going to be 4I rad 2. That's it. That's the simplified version. There's nothing else I could do with that. All right? Make sense? Okay, again, one more time, in case you missed it. What did I do? I just factored out the negative 32. I know it's negative 1 times 16 times 2. Square root of 16 is 4. Square root of negative 1 is I. Simplified is 4I rad 2. Number 2, okay? This is an imaginary number. We know that this could be imaginary. 7. 7 is real, okay? It's a regular constant, right? 7 is real, okay? Just like $7 is real in your pocket, right? You go to the store or you go to the Habit, they're like, your meal is $7. You could really take out $7 real dollars and give them that, right? Or you could be like, I have 7 imaginary dollars. I learned this in math, okay? And they're going to be like, get out of here, right? Right. So, rad negative 18 plus 7. You just work on the imaginary part first, so we know rad negative 18 is going to be negative 1 times 9 times 2 plus 7. What? I'm doing that with you. You don't have to. You could realize it's negative and just go to I. Okay? I just do that so you all see that. What's the square root of a negative 1? I. What's the square root of a negative sign? I. It's the same thing. Okay? So square root of negative 1 is I. Square root of 9 is 3. Square root of 2, we don't have that, so we're just going to leave that in there. 7 is just a real number. Okay, now we simplify. We always put the coefficient in front. So it's going to be 3. I times 3 is 3I rad 2 plus 7. Okay? And when we have a number like this is called a complex number. There's 2 parts. So we always put the real part first, which is just the real number, which is 7. So you should write it as 7 plus then the imaginary part, 3I rad 2. Okay? So this 7 represents the real number, or the real part. And then the 3I rad 2 is the imaginary part. That's the imaginary number. Okay? And these together, when we have the real part plus the imaginary number, this is called a complex number. Okay? We're not going to go into theory on any of this. We're just going to kind of touch on this for the next few days. And you kind of just need to know what it means. Okay? And when you go into higher level math, you do. Yep. Okay? Any questions? Yeah.
How do you check the answer if it's correct?
How do you check the answer if it's correct? Then you would just multiply this in. So what's 3 squared? 9. So 9 times 2 is? What's I squared? Negative 1, right? Remember that first box I made with all the i's? Negative 1. Okay? So that's how you check it.
Oh, if we ran into a problem that has, we don't have to use the, I to the third power. We were actually running those kind of problems.
I to the third power?
I to the second or third.
Yeah, you will. We're going to do that later. You're going to do like I to the 100 something. We're going to talk about how do you solve that. Okay? Which is super easy. You'll be like, oh, that's easy. Okay? All right. Write this down. Go. Number 3, let's see if you remember how to do this. I showed this at the very beginning. Hopefully you remembered. I'm just redoing it so that you get an opportunity to do it yourself. Okay, give you another 20 seconds to put the answer down. Okay, answers up. Okay, good. 2i. 2i. Excuse me. 2i. Okay, next one. This one's a complex number. We got rad negative 16 plus 4. Go. You know that you did it correctly. So negative 16, or negative rad 16, I'm sorry, rad negative 16 is going to be 4i, right? And then 4 is the real part, so we write that first. It could be 4 plus 4i is the correct way to annotate this complex number, okay? Okay, does that make sense? Sure. All right, here we go. Number 5 is a little taste of what we're going to do tomorrow. It's 7 minus 5i plus negative 7 plus 3i. So let me do that one with you, number 5. So you could add and subtract imaginary numbers or complex numbers, but you have to just keep the real parts together and the imaginary parts together. So let's work on the real parts. So we got 7. So we know 7's a real number. We know negative 7's a real number, and we have the plus sign in the middle. So 7 plus negative 7 is 0, right? Would you all agree? And then we have negative 5 is a real number plus a positive 3. I'm sorry, negative 5i is an imaginary number plus 3i is an imaginary number. So negative 5 plus 3i is negative 2i. So that would be your answer. It'd be 0 minus 2i, or you could just put simply negative 2i is fine. Okay? That's not hard. We're going to work on this again tomorrow. Super easy. Number 6, let's get that done. Go. Okay, so we got negative 5. This is two real numbers. Negative 5 plus, we know it's a plus sign in the middle. Negative 4 is negative 9. And then we got negative 6 plus 3i is going to be negative 3i. And that's it. We box that answer.
I thought a negative plus a negative was a positive.
Yeah. It's okay. That's why we make mistakes in class, so that you're learning as you go. It's okay if you make mistakes. Okay, and that concludes our lesson. So please turn off your iPads.